This video is on the resolution of forces. So basically how we can apply triangular forces and what we know about the sum of three vectors adding to zero on forces that are on a slope or a plane. So when we're looking at forces on a slope or on a plane, we're basically looking at a force acting on an object. And there'll be three forces acting on any object on a plane. Looking at this car, it's right now on the world's steepest street. If the brakes are on, we have a force that's pulling the car backwards to stop it from rolling down the hill. This is sometimes just called a friction force, or we call it F. We also have gravity pulling the car directly downwards towards the earth, keeping it on the ground. This gravity force will have strength the same weight of the car. We also have a final force that we look at in this course, and that is called the normal force. The normal force is a force acting upwards, and it is always perpendicular to your plane. In this case, the force kind of looks like it's perpendicular also to our friction force, but this is not always the case. Just remember the normal force is perpendicular to the plane which the object is resting. Here are our examples. The first one says a mass of 15 kilograms. The 15 kilograms tells us what gravity will be here. So the gravity force will be equivalent to 15 kg WTs. And this force is maintained at rest. If it's at rest, remember that our object is in equilibrium. And that gives us an indication that maybe we can use a triangle of forces. The mass is at rest on a smooth inclined plane. So just imagine this to be like a ramp or a hill. And it's resting there because a friction force is acting parallel to the plane, which you can see in the diagram below. We need to determine the magnitude of the friction force, our force F here, if the plane itself, so the hill or the ramp, is at a 30-degree angle with the horizontal. I'm just going to draw it a little bit clearer here. We have our gravity force acting down with magnitude of 15 kg WT. Parallel to our plane, acting on the object, is our friction force F, and we need to find the magnitude of this. We also have our perpendicular force to the plane or our normal force to the plane. Like I said, because our friction force is parallel to the plane, this means the normal force will also be perpendicular to our friction force, but this is not always the case. Finally, we know that the angle between our plane and the ground, or the horizontal, is 30 degrees. We have to start adding in angles between each of these forces or each of these vectors. So we know pretty obviously that the angle between the normal and the friction force is 90 degrees, and drawing your object as a square actually helps this a lot. Also notice, because the friction force is parallel to the plane, which is always 30 degrees from the horizontal, I can add a little angle in here. So my friction force to the horizontal must also be 30 degrees. And then notice that the horizontal and gravity, as gravity is vertically down, well, that will have an angle of 90 degrees here. In this way, I can find the angle between my friction force and my gravity force. Altogether, we see that this angle will be 30 plus 90, which is 120 degrees. Now we have two angles here and one magnitude of our force. This means we have enough to draw in our triangle of forces, because again, this object is in equilibrium. I'm going to start with gravity. Then I'm going to add on our friction force, and then I'm going to add on our normal force. Notice that in the original diagram, I let the angle between gravity and our force be alpha 1, between our force and the normal force be beta 1, and between the normal and gravity be gamma 1. So when we come to our triangle, remember we need the matching angles in this triangle. So my angle between gravity and my friction force in the triangle, I'm going to call that alpha 2, between the normal force and our friction force beta 2, and the normal force and gravity gamma 2. We know from what we did last lesson that alpha 1 plus alpha 2 is equal to 180 degrees. Because alpha 1 we said was 120, alpha 2 will be 60 degrees. Looking at beta 2, we know that beta 1 plus beta 2 would be 180 degrees. And from our original, beta 1 is 90, so beta 2 nicely is also 90. Add these angles into your diagram, and we can see that our last angle here, by the angle sum of a triangle, is going to be equal to 30 degrees. So now you have to choose how can you figure out what the magnitude of our friction force is. If I use cos 60 is equal to the magnitude of our friction force over the magnitude of gravity force, which was 15. As you can see from the diagram, not very clearly, that the hypotenuse is that gravity force. In this way, we get that the magnitude of our friction force is, take the 15 up, we'll get 15 cos 60 kgWt. And we know that cos 60 from our identity triangles is equal to a half. So we'll get that the force is 7.5 kgWt in strength. This part B has a variation. The plane is still at 30 degrees to the horizontal, but instead the friction force is at an angle of 10 degrees to the plane. So the friction force is no longer parallel to the plane. It will be up slightly. Let's draw our diagram. We still have gravity, that's the same as before. We also have the 30 degrees of the plane to the horizontal. And our normal force is also, again, perpendicular to the plane. We know that if our friction force was parallel to the plane, it would be something like this. If it's 10 degrees to the plane, that means it's actually up here. And that little angle between our friction force and its parallel component, I guess, is 10 degrees. Now, again, I know this parallel component to the plane must be 30 degrees. And now I can find out some angles here. We can see that that missing part between our friction force and gravity is 90 degrees. So the whole thing between our friction force and our gravity force would be 10 plus 30 plus 90. I'm going to call this alpha 1. This comes to 130 degrees. Notice I can also find the other two angles, but it's easy for me to find the angle between N and F. I'm going to call this beta 1. Usually, the angle between our normal force and our friction force when it's parallel to the plane is 90 degrees. But our friction force takes 10 degrees away from this. That means this angle is simply 80 degrees in this case, between our normal and our friction force. I'll add the vectors in the same order I did before. gravity first, then I'll add on our friction force, and then I'll add on our normal force. Notice these are not to scale, and we are again trying to find this friction force here and its magnitude or strength. So we have the angles alpha 2, beta 2, and gamma 2 matching with the above diagram. Very quickly, we know that alpha 1 plus alpha 2 is 180 degrees, where alpha 1 is 130. That means alpha 2 would be 50. Beta 1 plus beta 2, well, that would be 80 plus beta 2 is equal to 180. So beta 2 is equal to 100. Finally, by the angle sum of a triangle, I can find gamma 2. That will just be 180 minus 50 minus 100, or 30 degrees. Once you've put all the angles in, you can use some trig ratios. Because we don't have a right angle triangle, I'm going to use the sine rule. So I'm going to say the magnitude of force F over sine 30, its opposite angle, is equal to the magnitude of G over its opposite angle, so sine 100. We know the magnitude of gravity is 15, and then we just rearrange. In the exact form, we get 15 sine 30 over sine 100. Of course, in the exam, you can simplify this. And know that one of the most powerful forces in human nature is the belief that change is possible.